Now let's talk about hydrogen bond. When a dipole-dipole interaction, ठीक है, occurs between an oxygen and an hydrogen, or a nitrogen and an hydrogen, or a fluorine and an hydrogen. In तीन cases में we mention hydrogen bonding, which is a special type of intermolecular force with some characteristics of dipole-dipole attraction and some of a covalent bond. It consists of a hydrogen atom sandwiched between two very electronegative atoms, and there are conditions that have to be presented for hydrogen bonding to occur. You need a very electronegative atom with a lone pair of electrons covalently bonded to a hydrogen atom. Water molecules fulfill these conditions where oxygen is much more electronegative than hydrogen, तो polar बन जाता है. Oxygen atoms in water have lone pair of electrons. अब यहाँ पे ना ये lone pair होते हैं. There are two types of pairs in a molecule. एक को हम कहते हैं bond pairs such as this one जो यहाँ पे है. These are bond pairs. और फिर
Yeah.
आते हैं lone pairs which are not bonding at the moment. And remember these two terms because these two terms are very important when we are going to talk about the shapes and structures of the molecules. In water, the
Right.
hydrogen atoms are electron deficient, and this is because the oxygen is very electronegative and attracts the shared electrons in the bond towards it. The hydrogen atoms in water are positively charged and very small. These exposed protons have a very strong electric field because of their small size. तो अभी लोन पेयर ऑफ इलेक्ट्रॉन क्या करता है ऑक्सीजन में ऑफ अनदर वाटर ये मॉलिक्यूल स्ट्रांगली अट्रैक्ट हो जाता है ये जो पॉजिटिव हाइड्रोजन है इट गेट्स अट्रैक्टेड वेरी मच टू दीज lone pair of electrons क्योंकि ऑक्सीजन के ऊपर नेगेटिव चार्ज है. This strong intermolecular force is basically called the hydrogen bond, and they are even considerably stronger than the dipole-dipole interactions, but weaker than a covalent bond. Got it?
Yeah.
So when do hydrogen bonds form? Water is not the only example of hydrogen bonding. In order to form a hydrogen bond, there must be the following. अब NH3 में भी है hydrogen bond. NH3 और H2O. ठीक है अब ये H2O और NH3 ये भी आपस में हाइड्रोजन बॉन्ड बना सकते हैं. You have nitrogen, hydrogen and oxygen present. A hydrogen atom that is bonded to a very electronegative atom which contains nitrogen, oxygen, fluorine. These are the three most electronegative atoms in the periodic table. This will produce a strong partial positive charge on the hydrogen atom and a very electronegative atom with a lone pair of electrons. These will be attracted to the partially charged hydrogen atom in another molecule and form the bond. So the only atoms that are electronegative enough to form hydrogen bonds are oxygen, nitrogen and fluorine. जैसे कि ammonia molecule हो गया, hydrogen fluoride molecule and water. These are the three important molecules जिनके दरमियान you can find hydrogen bonding intermolecular force. The nitrogen hydrogen oxygen system is linear. This is because the pair of electrons in NH covalent bond repels those in the hydrogen bond between nitrogen and oxygen. The linearity is also the case with hydrogen bonds. और इसी तरह इनके boiling points differ करते हैं. You can see H2O, HF, and NH3, these have very, very high boiling points. But if we compare these with all of these, obviously hydrogen bonding wale are quite higher. But if we compare water, HF, and NH3, you can see water has a higher boiling point, NH3 has a lower boiling point, even though all three of them have the hydrogen bonding. Now, the noble gases show a gradual increase in boiling point because the only forces acting between the atoms are actually van der Waals forces, and these increase with the number of electrons present. The boiling points of water, hydrogen fluoride, and ammonia are higher than all those of the hydrides of the other elements in their group. But yes, you can expect them to be lower because बाकी van der Waals forces are actually weaker than hydrogen bonding. Hydrogen bonding is present between the molecules in each case of these compounds, and the stronger intermolecular force of attraction make them more difficult to separate. अगर आपको question आएगा, why is the boiling point of water higher? Why is the boiling point of ammonia higher? Or why is the boiling point of hydrogen fluoride higher? You would answer that more energy and heat is required to overcome the strong intermolecular forces. Got it? This is the answer.
Yeah.
that you will write. So oxygen, nitrogen, fluorine are the three elements that are electronegative enough to make the hydrogen bonding possible. And what is the importance of this hydrogen bonding? Although hydrogen bonds are only 10% of the strength of covalent bond, their effect can be significant. इनकी बहुत सारी properties पे effect होता है जैसे कि the structure and density of ice as well. Uh, ठीक है, structure and density of ice के ऊपर इनका बहुत बड़ा effect है. Let me show you one thing about permanent dipole, induced dipole, and then